What's up everyone, welcome back. Patrick here, and in this video what we're going to do is introduce some measures of central tendency. And you've probably seen these, dealt with these before, but more specifically the three measures we're going to go over in this video are the mean, the mode, and then the median. I'm going to leave the median to the end because there's a lot going on. There's a lot more going on for median. It's a little bit more work than these two. There's certain cases that we have to deal with. So I'm going to go in this order right there. Now, I'm going to show you how it works through an example. So let's say we have a class of 9 students and they had the following percentage marks on a test. So notice there are 9 marks here, a set of marks for each student on this test. And let's say we wanted to figure out what the mean of this data here is. Well, the mean in general, it's basically the sum of all of the observations over the number of observations. So the sum of the observations in this example, if you summed all these up, you would end up getting 672. And divided by the number of observations is 9. We're looking at 9 marks. 672 divided by 9 would give us 74.67. So that is the mean or the average of this data over here. Now the mode is the observation, or there could be multiple observations with the largest frequency, or the observation that comes up the most. And notice if we look at this data here, which mark is coming up the most? Looks like this 78. I don't think there's any other ones. Yeah. The other ones are all unique. So 78, notice that it comes up twice, while all of the other marks, they're all just coming up one time each. And so the mode, in this case, would be 78. And because, I want to mention this too, because there's only one mode, remember from the previous video, we talked about unimodal versus bimodal. So this here, this set of data, is unimodal because there is only one mode. Now, if we had another 10th mark here and it was 82, well, notice there would be 2 modes then. There would be 78 and 82. You would write them both, and then this data would be bimodal because there are 2 sets of modes. Yeah, but in this case, there was only one set. It was the 78, so this data here is unimodal. But if there are multiple sets of modes, multiple observations with that same highest number of frequency, you would just write out all of the observations. And then finally, the third measure is the median. And as I mentioned, it's going to require the most work. So it's basically the middle observation in the data when it's arranged from smallest to largest, or vice versa, usually from smallest to largest. So the reason why it requires the most work is because we have to arrange it from smallest to largest. And notice that all of these values, they're all kind of mixed up. So if we take all these values, arrange them, starting with the lowest value. So the lowest value is 47. The next value would be 61. The next value would be 72. Next value would be 76. And then we would have 78, and it appears twice. So we would write it twice. And then the next one would be 82, 84, and then 94. Right? So that is those 9 observations written from smallest to largest. Now with the median, there's actually 2 cases. So notice here we have 9 observations. So there's a case where there's an odd number of observations, which is the case we're doing now. And then there's also going to be a case with an even number of observations. And what I'm going to do is I'm going to add another mark to the data and show you how the median will change in the process of finding it, how it'll be a little different. Now, with an odd number of observations, it's nice because it's just the single observation in the middle position. So whenever you have an odd number of observations, there's always going to be a single observation in the middle. And there's a couple of ways to do it. One way is if we pretend these are all positions, so this is like position 1, 2, 3, 4, 5, 6, 7, 8, 9. The position of median, it's always going to be the number of observations, let's call it n, plus 1 divided by 2. So remember, n here is the number of observations. So in this case, how many observations are there? There's 9. So it would be 9 plus 1 divided by 2, which would give you 5. So it's the fifth value, the fifth observation, the fifth position that is the median. So 1, 2, 3, 4, 5. And so the median is just going to be the 78. Another way you can do this is instead of looking at the position number, which is actually the way I recommend doing it, another way, it'll take you longer if you have a larger set of data, is you could just start crossing out the smallest and largest values and kind of work your way in. So cross this, cross that, cross this, cross that, cross that, cross that, and then that single number you're left with is going to be the median. So either way you do it, the median for this set of data is 78. Now, what if there's an even number of observations? So notice that I have the same data, but I added this 44 at the beginning. So instead of 9, there are now 10 observations, which is an even number. How is the process for finding the median going to change? Well, this formula is still going to stay the same. So if we write out the positions, we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But in this case, the n, the number of observations, is going to be 10. So you'd go 10 plus 1 divided by 2, which would be 11 divided by 2, which would be 5.5. And notice that 5.5 is in between these two right there. That's where 5.5 is. And so with an even number of observations, what you're going to have to do is you're going to have to take the average of the two middle observations. Because with an even number of observations, there's not going to be a single middle observation. There's going to be two of them. So notice that if we cross this out, cross that, cross this, cross that, cross this, cross that, and then cross this and cross that, we end up getting here with these two middle observations. There's not a single one left. And so the 5.5 basically means we got to average out these two middle observations. So what we would do, the median, would basically be 76 plus 78 divided by 2, which would give us 77. And so the median in this case would be 77. The median can also be a decimal. Like let's say this value here was 77, then 77 plus 78 divided by 2 would give us 77.5. So you can have decimals for the median as well. So with an even number of observations, it's a little bit more work at the end because you got to average out those two middle terms. If there's an odd number of observations, it's nice because you're just going to have that single observation in the middle.